Alright, so in this problem, I have 4 to the power of x minus 2 to the power of x is equal to 1. So to solve this, I'm going to first start by subtracting 1 on both sides. So then these two cancel out, and I have 4 to the power of x minus 2 to the power of x minus 1 is equal to 0. Now, I'm going to rewrite 4 to the power of x as 2 to the power of 2 to the power of x. And now if I have something in form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can switch these two exponents. So now I have 2 to the power of x to the power of 2 minus 2 to the power of x minus 1 is equal to 0. Now I'm going to let 2 to the power of x equal to the variable y. So now I have y minus 1 is equal to 0. Sorry, y squared. So now to factor this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So I have y is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. This is equal to 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So y is equal to 1 plus the square root of 5 over 2, and it's also equal to 1 minus the square root of 5 over 2. Now remember how we set 2 to the power of x equal to y. So if 2 to the power of x is equal to y, and we already have two values of y here, then we can simply set these equal to each other. So first off, I have 2 to the power of x is equal to 1 plus the square root of 5 over 2. So to solve this, I'm going to take the log on both sides. So then I have x times log 2 is equal to log 1 plus the square root of 5 over 2. And now if I divide both sides by log 2, these two cancel out, and I get x is equal to log 1 plus the square root of 5 over 2 over log 2. Now for y equals 1 minus the square root of 5, well, 1 minus the square root of 5, that's going to be a negative number. And you can't take 2 to the power of a positive, 2 to the power of any number and make it negative. So this is wrong, and my only solution is right here. Alright, so in this problem, I have 2 to the power of 20 minus 1. So to solve this, I'm going to first rewrite 20 here as 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2, that's going to be equal to, we can think of 10 as m here and 2 as n. So it's going to equal 2 to the power of m, which is 10, to the power of n, which is 2, minus 1. Now, 1 here, this is the same thing as 1 to the power of 2, because 1 to the power of any number is simply just 1. So I'm going to rewrite 1 here as 1 to the power of 2. So now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And in this case, a is 2 to the power of 10, and b is 1. So I can rewrite this in the form 2 to the power of 10 plus 1, a plus b, times a minus b, so 2 to the power of 10 minus 1. Now, if you guys already didn't know, 2 to the power of 10, this is equal to 1024. So I have 1024 plus 1 times 1024 minus 1. And 1024 plus 1, that's simply 1025. So I have this times 1024 minus 1, which is 1023. Now, to make this easier to solve, I'm actually going to rewrite these. I'm actually going to rewrite 1025 so that it's in the form 1000 plus 25. And I'm going to do the same thing to 1023. I'm going to rewrite so that's in the form 1000 plus 23. And the reason I'm doing this is because it's much simpler to solve. So first off, all I have to do is distribute 1000. So I have 1000 squared plus 23 times 1000. Now if I distribute 25, I have plus 25 times 1000 plus 25 times 23. This is equal to 1 million plus 23,000 plus 25,000 is 48,000 plus 25 times 23 is 575. And this is equal to 1,048,575. All right, so in this problem, I have 5 to the power of x plus 2 is equal to 4 to the power of x. So to solve this, I'm going to first start by taking the natural log, or ln, on both sides. So now I have ln 5 to the power of x plus 2 is equal to ln 4 to the power of x. Now if I have something in the form ln a to the power of b, I can move this x1 and b to the front, so this can equal b times ln a. So in this case, I have ln 5 to the power of x plus 2, and x plus 2 here, I can move to the front. So now I'm going to have x plus 2 times ln 5. And I can do the same thing with x over here. I can move x to the front. So now I'm going to have x times ln 4. Now, if I go ahead and distribute the ln 5, I get ln 5 times x, which is x times ln 5, plus 2 times ln 5, which is 2 ln 5, is equal to x times ln 4. Now, from here, I'm going to subtract x times ln 4 on both sides. So I have x times ln 5 minus x times ln 4 plus 2 times ln 5 is equal to 0. Now if I subtract 2 on ln 5 on both sides, these two cancel out and I get x times ln 5 minus x times ln 4 is equal to negative 2 times ln 5. Now if I factor out x, I get x times ln 5 minus ln 4 is equal to negative 2 times ln 5. Now if I divide both sides by ln 5 minus ln 4, these two cancel out and I have x is equal to negative 2 ln 5 over ln 5 minus ln 4. Now, ln 5 minus ln 4, that's the same thing as ln of 5 over 4. So, I have x is equal to negative 2 times ln 5 over ln 5 over 4. This is my answer.